All right, hello everyone, and welcome to another day of Math 9 in British Columbia. Today we're looking at notes for 4.2 adding and subtracting polynomials. So by the end of this lesson, you should be able to apply mathematical understanding of like terms in algebraic expressions, model and record the process of adding and subtracting polynomial expressions, and solve problems using the addition and subtraction of polynomials. So today's lesson is similar to last day's, with the exception that we will strictly be focusing on how to add and subtract polynomials. So last day's lesson was combining like terms and how we would bring them together based on the variable that they had and also the degree of those variables. So we'll get right in here looking at example number 1 here, where we're going to be adding polynomials first. So we're looking to add 3x minus 4 and 2x plus 5, and we want to simplify our answer by combining any like terms that would be left off. All right, so when we add polynomials, we need to make sure we put each polynomial in its own brackets to start off. So let's do that. So I'm going to put bracket 3x minus 4, close bracket, plus, because I'm adding the polynomials, bracket 2x plus 5. Okay? And then from there, we multiply in a plus 1 and simplify. So what this is saying here, we haven't looked at distribution yet, so this might be a little bit new. But the way that we get rid of brackets in mathematics is that we multiply the coefficient in front of the bracket to the numbers inside of the bracket, and then that makes the bracket disappear. Okay, then we're able to drop our brackets. And so because there's nothing in front of the first bracket here in front of the 3x, I can assume that what number would be in front of that bracket. I can assume here that there's the number 1 in front of this bracket, and the second one here, same thing, so plus, and then there's nothing in front of the second bracket in front of the 2x plus 5 here. I can assume that it's plus 1 times 2x plus 5. Okay, so those are the assumptions that we're making here. So that's why it says here that we're going to multiply in plus 1 into both of our brackets and simplify. And so using distributive property, which we'll look at a little bit more, but we know that in future lessons, but we know that when we multiply 1 times a number, we just end up with that number. So 1 times 3x minus 4 is going to give me 3x minus 4 without the brackets. And then positive 1 here, positive 1 times 2x plus 5 is just going to give me a positive 2x plus 5. So essentially, all that to just drop the brackets, which we're able to do when we're adding polynomials together. We can just drop the brackets, and then all that's left to do is combine like terms. So I want to find my like terms. I can see that 3x have the same variable at the same degree and 2x to 2x, and so those are like terms. So 3x plus 2x, right? And then the other two are negative 4 and positive 5 here. So remember to include the sign in front of your terms. So this was minus 4 plus 5. All right, so those were our other two terms there. All right, and then we add them together, we get our final answer. So 3x plus 2x gives me 5x, and negative 4 plus 5 gives me positive 1. And that would be your final answer. All right. See if you can make sense of this explanation. It's your turn, so go ahead and pause the video and try to answers here B, C, and D, and then come back and see if you got the answer correct. All right, hopefully by now you've been able to answer all 3 questions correctly. You might have gotten stuck along the way. That's okay. We're going to go through all 3 of them together. So the first one we're going through is 2a minus 1 plus 6 minus 4a. And again, because these polynomials here are being added together by that plus sign, I'm multiplying positive 1 to both brackets, which means I end up just getting rid of both brackets because 1 times any number is just that number. So I end up with 2a minus 1 plus 6 minus 4a. Okay, then I want to combine my like terms. I can see that here I have 2a and negative 4a, or minus 4a, so 2a minus 4a, and then I have negative 1 plus 6, negative 1 plus 6, right? I'm going to group them together. Here you don't have to do this step of moving them next to each other. You can go ahead and go directly into the answer by adding the two like terms together. You don't have to do this step here. I'm just doing it to show you guys clearly. 2a minus 4a is negative 2a, and negative 1 plus 6 is positive 5, and that is your final answer. Moving on to the next one here, again, we are adding two polynomials, and so we're multiplying 1 to both of the polynomials, which means we're dropping the brackets. So I can rewrite this as just 3t squared minus 5t plus t squared plus 2t plus 1. Okay? Now you might be wondering, why did he spend so much time talking about multiplying by 1 if we're just dropping the brackets and nothing changes anyways? Well, that'll show up a little bit more clearly when we talk about subtracting polynomials, okay, which is just on the other side of this page. But for adding polynomials, you're right, it doesn't make much of a difference. But we'll see what kind of situation it does make a difference. So I have all my terms here. I want to start identifying my like terms, grouping them together, and getting the answer. Okay, in this stage, I'm not going to rewrite them like I did in this step on the previous question. Okay, I'm just going to highlight them and then get the answer right away. So 3t squared plus t squared gives me 4t squared. Negative 5t plus 2t gives me negative 3t, and then all I'm left with is that plus 1. So I do plus 1, and I get my final answer. Okay, so I skipped a step there, but you guys saw that they combined. Many of you guys have probably started skipping that step a long time ago. Last one here of this example, same idea. We're adding polynomials so we can drop the brackets. I'm going to rewrite everything without brackets. Negative 7b cubed c plus 5bc minus c squared plus 14bc minus 8c squared plus 9b cubed c. All right, so brackets are gone. Because I'm adding polynomials, now all I have to do is find my like terms. Negative 7b cubed c plus 9b cubed c is going to give me 2b cubed c. Positive 5bc plus 14bc is going to give me positive 19bc. And the last one here, I'll get a different highlighter color for you all. Negative c squared minus 8c squared is going to give me negative 9c squared. Okay, you have to see that negative c squared as negative 1c squared. Okay, lots of invisible ones when we're dealing with polynomials. You got to see them there. Okay, hopefully that is becoming easier and easier for you guys to do as you familiarize yourselves with these types of problems. So before we jump into subtracting polynomials, first we're going to do a little exercise that'll help us better understand what exactly we're doing when we're subtracting polynomials. So first we're going to ask this question of to determine opposite expressions. Okay, so what is the opposite for each of the following? What does it mathematically mean that when we say that a number is opposite another number? Okay, well the answer is that the opposite of a number is just that same number, but a negative coefficient instead of the positive coefficient in front of it. Okay, so the opposite of 3x would be negative 3x. Okay, it's as easy as that. Okay, so if I were to ask you, what is the opposite of negative 2? It would be the negative of negative 2, or it would be positive 2, right? So you just either, if it's a positive, you put a negative. If it's a negative, you put a positive. You guys can see what's going on here. The negative of 4x minus 1. Okay. So here, so you're essentially, in these ones here, what I essentially did was multiply negative 1 to my number to solve for my opposite term. So here, I did negative 1 times 3x is equal to negative 3x, right? You see that? Negative 1 times negative 2 gives me positive 2. So using that negative 1 can make things positive or negative depending on the sign of the term that you start with. So in this situation, I'm going to do the same thing. Negative 1, okay, and that's going to be multiplied to 4x minus 1, okay? Again, distributive property is something that we haven't looked at a ton yet. It's in a future section. But essentially, you're multiplying the negative 1 to the 4x, and you're multiplying the negative 1 to the negative 1 in the back. Okay, so this is going to give me negative 1 times 4x is negative. Here, let me just rewrite what I just explained. So negative 1 times 4x, and then negative 1 times negative 1, right? Those are the two things that we're going to be putting together. So we're going to put plus between those. And so negative 1 times 4x is negative 4x, and negative 1 times negative 1 is plus 1. Okay, so the opposite of 4x minus 1 is negative 4x plus 1. Okay, so we see that the 4x, the 4x became negative 4x, and then negative 1 became positive 1, which is what we would have expected. And so here, last one, same thing. You see that each term becomes the opposite of the term that's given to you originally. So a squared would just become negative a squared. Negative 3a would become positive 3a, and positive 2 would become negative 2. Okay, and again, what you're doing is I'm taking that negative 1 and I'm multiplying it to the a squared minus 3a plus 2. Okay, so it's negative 1 times a squared, and then negative 1 times negative 3a, and then negative 1 times 2. And you'll see that it gives you what we came up with for our answer for what is negative. Okay, so it's the opposite signs for the coefficient of the terms that you have. All right, don't worry about that homework assignment yet. That'll be assigned at the end of the notes. Okay, so example 3, subtract polynomials. So now you're going to use the skills that we talked about here and apply them to subtracting polynomials. All right, so we have two polynomials given to us here, 2x plus 3 and 3x minus 4, and we were going to want to simplify our answer by combining like terms. So just like last time, we're going to put the polynomials in brackets, but now instead of separating the brackets with a plus sign, because we were adding polynomials before, we're going to separate the brackets with a minus sign because we are subtracting the polynomials. However, we'll need to do something different this time when we remove the brackets, okay? So just like last time, in order to get rid of a bracket, the idea is that you're multiplying the bracket by the coefficient in front of the bracket. So for the polynomial on the left, I'm multiplying the polynomial by positive 1, and I just end up with exactly what I had there before, which is 2x plus 3, right? 2x times 1 is 2x, 1 times 3 is 3. But here, notice that if I assume that there's an invisible 1 beside the second bracket, now the coefficient in front of the second bracket is a negative 1. So now I'm multiplying negative 1 to both terms inside. So the negative 1 times 3x turns this into a negative 3x, and the negative 1 times negative 4 turns this to a positive 4. Okay? Also notice that negative 3x plus 4 is what you would have gotten had I asked you what was the opposite of 3x minus 4, right? You would have said, oh, that's negative 3x. and it's a minus 4, so I'm going to change it to a plus 4, right? That's what you would have said, most likely, if you understood what we were talking about in opposites here before. So that you're getting the same thing after you've done those steps. Okay, let me just erase the highlighting here. So now I'm at this stage. I don't have any more brackets, which is what I want, because now I can simplify my like terms. And so here I have 2x minus 3x, and I have positive 3 plus 4. And so that gives me negative 1x, or negative x, plus 7 as my final answer. Okay? See if you can make sense of this in the Your Turn section. A, B, and C once again. Do notice that the finding the opposite of the polynomial that we're subtracting, that only applies to the second set of brackets, okay, the one that's being subtracted. All right, the first set of brackets you see on the left, because you're multiplying by positive 1, so nothing changes on the first set of brackets. It only changes on the second set of brackets, because that invisible 1 actually becomes an invisible negative 1. And that negative 1, when multiplied into your polynomial, is going to give you the opposite of that polynomial. In this case, negative 3x instead of positive 3x, and positive 4 instead of negative 4. Okay? All right, so go ahead, pause the video, try the Your Turn questions, and I'll be explaining them here once you unpause the video. All right, hopefully those questions went well for you. If you got stuck along the way, again, I'll be going over these, all 3 of them here. So let's get to it. So again, I am picturing that invisible 1 in front of both of these brackets, that 1 there and a 1 there. This just gives me 1 times 2x minus 3, and it's multiplied by positive 1, so nothing changes. I end up with 2x minus 3. Nothing changed, okay? Because it's distributing a positive 1 into my bracket. Nothing changes. Here, now I've got a negative 1. Because I added that invisible 1, it's a negative 1, not a positive 1. And when I multiply a negative 1 to each term inside of the bracket, I end up with the opposite term inside that bracket. So negative 1 times negative x gives me a positive x, okay? And negative 1 times positive 2 gives me a negative 2, okay? Again, notice that the polynomial you got before and the polynomial you end up with are opposites. You went from negative x to positive x and positive 2 to negative 2, okay? That's how you know that you've subtracted or you've applied the negative inside of your brackets properly. Okay, I'm going to erase some of these lines here, make it not so messy, because now I have to combine my like terms. I'm not done. I have to simplify 2x plus x, and I have negative 3 and negative 2. So 2x plus x gives me 3x, minus 3 minus 2 gives me minus 5, and that's the answer for that question. All right, some of these problems are a little bit longer, but same idea here. I have a 1 in front of both. The first one doesn't do anything because it's a positive 1, so I get 5x squared minus x plus 4. And then the negative 1 here that I've created by adding that 1, or it was always there. I'm not adding a 1. That invisible 1 was always there, okay? So that negative 1 is multiplied to all 3 terms, and that's going to give me the opposite of the, in this case, trinomial inside the brackets. So negative 1 times 2x squared is negative 2x squared, which is also just the opposite of 2x squared. It's negative 2x squared. The opposite of negative 3x is positive 3x. And the opposite of negative 1 is positive 1. All right, so now I've applied that negative 1. I can drop my brackets, and I can finish by combining my like terms as such here. I need a 3rd color highlighter. I need to just add a 3rd highlighter, I think. That will speed up the process. There we go. And I write out my answer. 5x squared minus 2x squared is 3x squared. Negative x plus 3x is positive 2x. And 4 plus 1 is 5. Final answer. All right. Last question here. I'll leave the top one visible so you guys can keep looking at that. Or you can pause the video, rewind, whatever you want to do. Put that 1 here. I show it. It was always there, but I show it now. In the first bracket, because it's a positive 1, doesn't do anything. So I end up with 4a squared b plus 9ab. And then here the negative 1 in front of the bracket changes the polynomial inside the bracket to its negative, or its opposite, right? So the opposite of 8a squared b is negative 8a squared b, which is what negative 1 times a squared b is equal to. The opposite of positive 5 is negative 5. The opposite of negative 16ab is positive 16ab, right? And that's what you get by multiplying negative 1 to all 3 of the terms. Now that I've multiplied my coefficient in the bracket, I have no more brackets. And so I can combine like terms and finish this question and these notes for today. So 4a squared b minus 8a squared b is 2 of my like terms. And then I have 19ab plus 16ab. And then I have that lonely negative 5 there. So I end up with negative 4a squared b plus 25ab minus 5. And that would be your final answer. All right. As we finished our notes here, I want you guys to just kind of do a little self-checkup here. See if you've been able to accomplish and understand clearly the things that we set out to do in these notes. Can you apply mathematical understanding of like terms in algebraic expressions? How do you feel about that? Do you still feel like you have no idea how to do this? You kind of know what you're doing, or you feel like you're pro, you got this, everything was clear, no questions. Next point, can you model and record the process of adding and subtracting polynomial expressions? So just adding the brackets, what we were doing at the beginning, and then solving problems using addition and subtraction polynomials. You'll see some word problems that apply this principle in your homework. So now that you've done this, your homework is assigned to you, and the due date will be in the Teams app. All right. If you'd like a digital copy of the notes that we use to cover this content here, and you are not currently in my Teams classroom, whether you're watching this on YouTube or somewhere else, I will link these notes in the YouTube comments below as well. Thank you and have a great day.